Climate change may also have longer lasting effects on the economy. The estimates in this picture that I've now shown many times do not consider that at all. They only study the impact of climate change on a particular point in time. In order to understand the impacts of climate change on economic growth, we need to have a bit of a closer look at the impacts on the economy. Climate change can affect welfare through 4 different channels. The first is a direct effect on utility. Species may go extinct, and if that happens, we feel sad, but it does not really affect the economy. Climate change may also affect labor. People may fall ill, or worse, they may die, and as a result, they are no longer available in the labor force. Climate may also reduce productivity. For instance, crops may fail, and this would lead to a reduction in the output and consequently a reduction in the output per worker. And then finally, climate change may directly affect the capital stock. For instance, a flood may wash away our buildings or our roads. These insights are due to Sam Fankhauser, who you see displayed here. Now that we understand the different effects of climate change in the economy, we can start looking at the different dynamic effects of climate change on the economy. If climate affects utility directly, there's no impact on the economy and therefore no impact on economic growth. However, if output is lowered in period T in this year because people are ill or because crops fail, because productivity has fallen, if output is lower this year, then that has 2 implications. One, we have less money to consume, but also we have less money to save and therefore less money to invest. And if we invest less today, then we have less capital tomorrow, and as a result, we have less economic output tomorrow. So that is a dynamic effect, that is an effect that lasts. Similarly, if our buildings get damaged by floods, for instance, then we have less capital left and therefore we have less output in the future. Now you can argue that this can be partly offset by people saving more. But that would not be a rational response, as you would cut consumption even more. In the initial effect, output falls and you take a cut in your consumption, and in order to compensate this, you need to cut your consumption even further, and that is probably too much to ask for people. It's also not a rational response, because if output has fallen this year because of climate change, it is a structural effect, then you would adjust your expectations so that the return to capital, the return to investments would fall as well. And exactly, you would want to invest less, not more. There's another countervailing effect, and that is if the effect of climate change is through the labor force, and if the amount of labor falls, if the labor force shrinks because more people are ill or worse, then of course there's more capital per worker, and that means that labor is more productive, and that means that people can command higher wages. Now, in a standard growth model, this would not offset the growth effects either, because essentially you have a surplus of labor. There is too much capital per worker, so you would actually, again, the rational response would be to consume this surplus of capital rather than use it. In a calibrated model, these effects are small. In a calibrated model that is applied to climate change, these effects are small because most of the health impacts that we talked about previously actually fall on the very young and the very old, and much less so on the people in the labor force. So this is not really a counter-argument either. So this is how it works in theory. These are the first principles. How big are these effects in practice? If we take a calibrated growth model, what do we see happen? Well, here is the first set of results. On the horizontal axis, we're looking at time. We're looking at time into the future. On the vertical axis, we're looking at the change in GDP. The bottom line that you see here is the assumed direct hit of climate change. This is the static impact. These are the estimates that we looked at before, and this is just an illustrative scenario. These impacts were then put into 4 alternative models of economic growth, and the 4 lines that you see here are the indirect effects. This is not what is the impact in year t, but what happens in year t plus 1 and t plus 3 and t plus and so on and so forth. And that if these are the indirect effects, that means that the total effect is the sum of the two. So that is how you should read this graph. Now, the 4 alternative climate models are first the Solo model, or the Solo Swan model, I should say, which has exogenous capital. Which has exogenous savings. The savings rate is just fixed, and it also has technological development that just happens for no particular reason. It is just manna from heaven. And if you specify your growth model as such, you find that the indirect effects are of the same order of magnitude as your direct effects. The Solo model essentially only has the capital accumulation effect that I talked about before, that if you have less output, then you save less and you invest less and you have less capital in the future. That's the only effect that is going on in the Solo model. If the indirect effects are of the same order of magnitude as the direct effects, and the implication is that all the numbers that I showed before are a factor too low. You should double these numbers. That is essentially what this graph says. The second model that you see here is the Ramsey-Cass-Koopmans model. The difference between Solo and Ramsey is that in the Ramsey-Cass-Koopmans model, savings is endogenous. In Solo, there's a fixed savings rate. In Ramsey, you re-optimize your savings. And if you look at this, then you see, well, this is actually basically the same. There's hardly any adjustment in your savings. So that does not do much. The third model is a new growth model. This is the Romer model. This is the model developed by Paul Romer and calibrated and operationalized, I should say, by David Romer. Paul and David are no relation of each other. And what you see is if you do use that model, the impact slightly increases. Now, what is the difference between Romer and Solo? Because the savings rate is again fixed. The difference between Romer and Solo is that in the Solo model, technological progress is exogenous. It just happens. In the Romer model, you actually have to work for it. You actually have to invest in R&D. Because of that, a larger part of the economy is endogenous. Climate change can affect a larger part of the economy, and therefore the impact slightly increases. It increases necessarily because you have more of the economy to affect, but the effect is small. The final model that you see is the Menke-Romer-Weil. Romer is David Romer again. And that has an alternative way of endogenizing technological change. Now, it's not investment in R&D, but it is investment in human capital. It's education. And again, you have a larger part of the economy that climate change can affect, and therefore the impact goes up. And it actually goes up quite a bit. So much so that I previously said, well, you should double these numbers, but if the Menke-Romer-Weil model is correct, then you should actually triple the previous estimates that I've shown. The question now is, of course, which of these models is correct? Well, Ramsey and Solo assume that technology just progresses out of itself. It's a silly assumption, so those models can be discarded. So the question really is Romer right or is Menke right? Unfortunately, both are wrong. If you take the Romer model, then you under-predict income dispersion across the world. You would actually find the model predicts that there's less inequality in the world than we observe. whereas the Menke's model predicts that there is more inequality in the world than we observe. So the truth lies somewhere in between the two. But we haven't quite found a model that can do that. Right, but the important takeaway message here is yes, there are these dynamic effects on the economy, and they are substantial. They can double or triple our previous estimates. Can climate change reverse economic growth? Well, if we take a standard scenario and the standard calibration, then this is the assumed economic growth without climate change, and then this is the resulting economic growth with climate change. So what you see is that climate change reduces economic growth, it decelerates the economy, but it does not reverse economic growth, it does not lead to economic shrink. This is the standard calibration. If we take the Menke's model, that is the most sensitive one, and we start pumping up the damages, the base specification here is 5%, then it does not happen, but you need to go to economic damages in the order of 10% or 15% in order for climate change to reverse economic growth, for the economy to start shrinking. Now, 10%, 15% is actually quite high, and it's not only that, this is the impact on the economy. So you need to argue that climate change would affect the economy by 10% or more. And you need to assume that the Menke's model is right. Because if you do the same thing in the Solo model, then the economic shrink is postponed till the end of the next century, and only if you assume very high damages. So yes, climate change affects economic growth, but reversing economic growth, economic shrink as a function of climate change, that is actually quite unlikely. Now this is theory. There's also empirical evidence. There's a little bit of empirical evidence for this. What you're looking at here is the work of Melissa Dell, who you see displayed here together with her colleagues Jones and Alken, published now 8 years ago. And what they did was a regression of the annual growth rate on the temperature and rainfall in that particular year. And what they find is very little effect in rich countries, or no significant effects in rich countries, but they do find significant effects in poor countries. These effects are substantial. They actually do not find much of effect of rainfall, but they do find an effect of temperature shocks on economic growth, and these effects are substantial, somewhere around 1.4%. And the way to read is that if it is unexpectedly warm by 1 degree, then for every degree that it's unexpectedly warm, economic growth falls by 1.4 percentage points. That is, if in a normal year you grow by 3.5% in a poor country, and in a particularly hot year you grow by 2.1%. So that is quite a big difference from 3.5 to 2.1%. The problem with this study, as I said before, that this is a weather study. This looks at the impact of weather shocks on economic growth, and it's unclear how representative this is for climate. And now Eric Strobel and colleagues have looked at this in a bit more detail, and this is actually a proper study about the growth impacts of climate change. What they noted is that in sub-Saharan Africa, if you look over the 20th century or so, you see a steady decline in rainfall. We've also noticed that sub-Saharan Africa is actually that part of the world that has the lowest economic growth on average. So they ran regressions of rainfall, regressions of growth from rainfall, not the other way around. And they do find significant effects. And then they did a whole bunch of dummy tests and compared Africa, sub-Saharan Africa, to places that had similar starting conditions. but did not have the decline in rainfall over time. um, and the effect seemed to be substantial, and that is shown in this particular graph here. So the solid line that you see here is the observed economic growth from 1960 to the year 2000 in sub-Saharan Africa. And then this line here, the dashed line, is the observed sub-Saharan growth, the observed economic growth in countries that are not in sub-Saharan Africa but had similar conditions as sub-Saharan Africa economically in the 1960s. So these two are directly comparable, and what you see is that, Africa's growth performance has been rather lackluster. They estimated this model, so they know the effect of the failing rains. So what they did in two counterfactual scenarios is they assumed that they asked the question, what if the rains in Africa had stayed as they were in the 50s and the 60s? And the result are these two lines. There's two alternative specifications. Data, you're never quite sure which model is the best, so they tried an optimistic model, a pessimistic model that shows a large effect of rainfall, and an optimistic model that shows a much smaller effect on rainfall. And what this picture shows is that if the rains in Africa hadn't fallen but had stayed as they were in the 1950s and the 1960s, then Africa would have grown about as much as Latin America and South Asia, or perhaps even stronger. And this suggests that yes, climate change, because this is a secular drop in rainfall, this is a declining trend in rainfall, not a one-year drought. Yes, climate change can have an effect on economic growth, and that is a substantial and notable effect.